Hey everyone, welcome to Sequences and Series. The objective today is going to determine if a series converges or diverges. And remember, an infinite sequence is a sequence of functions whose domain is the set of positive integers and is denoted by a sub n. So we want n to be an integer, right? So for example, a sub n equals 1 over n. And there's the sequence that follows. So a sequence is just a collection of objects, in this case numbers, okay? Now the objective is to be able to determine whether a sequence converges or diverges. So what we need to do is look at the definition of something that converges. A sequence a sub n converges to a finite number L if the limit as n approaches infinity of a sub n equals L. Okay, so your limit is going to converge on a number. Okay, if a sub n does not have a finite limit, we say that the sequence diverges or is divergent. So here is a couple of definitions we need to know, really what converging is, and then what does it mean for a function or a sequence here, to diverge and converge. Our first example, does the sequence a sub n equal 1 over n, does that actually converge or diverge? So I wanted to bring this example up because this is an example of a harmonic series. Here we go, harmonic series. And that's actually a p series where p equals 1, and this series diverges. So if we're talking about this, what a p series is, and there's a p series test, you might want to review that in order to determine or help you figure out why the series actually diverges. So, if I was going to use the definition though, I'd take the limit as n approaches infinity of a sub n, and my a sub n is my 1 over n. So I substitute that here, and if I plug in really large numbers for n, I get a very small number. So this actually goes to 0, but it's a special case. It's the harmonic series. It actually diverges and it does not converge. I wanted to show you this one first because this is a tricky one. Alright, example, does the sequence a sub n equal 1 plus negative 1 to the n power over n converge or diverge? So the idea here is we're going to be taking the limit as n approaches infinity of a sub n. So there's the setup. Now, what I want to do is I put in a few values for n. I can plug in 0, I can plug in 1, I can plug in 2, 3, 4, whatever I want to plug in. And these values are alternating being above and below 1. It's oscillating above 1, getting closer and closer. 0 to 1.5, 6.66, 1.25, 0.8, okay, 1 into 6. Okay, so we're getting, it's oscillating, but it's getting closer and closer, oscillating towards 1. So this sequence converges to 1 by oscillation. Okay, so that's converging. We're getting closer to a specific number. Okay, example, does the sequence a sub n equal n squared minus 1 over n, does that converge or diverge? So what we're going to do is look at the limit as n approaches infinity of a sub n, which is n squared minus 1 over n. Now, think about the limits. Back to that definition, we have a a numerator that has a larger power than the denominator. So by definition, this limit goes to infinity. So we say that this sequence is going to diverge. All right, last example here. Does the sequence a sub n equals sine of x converge or diverge? Now, this one also oscillates, but if you think about the sine function, it's going to oscillate between negative 1 and 1, and it's never going to change. It's going to go all the way out to infinity and never change. So the limit as n approaches infinity of the sine of x function does not exist. You might say infinity, but it doesn't exist here. It oscillates. But it does oscillate between negative 1 and 1. However, the sequence is going to diverge. You're not getting close to a number. Okay? So those are a couple examples of sequences that converge and diverge just based on taking or looking at the limit of that expression. We call that a sub n. So if you have any questions or comments, you can type below. We'll see you next time.